everyone, welcome to the first set of notes for college algebra. Today we're going to be covering 1.5, which is solving inequalities. We're going to focus on the notation that you're going to be using, and then we're actually going to get into solving equations and inequalities in 1.6. So one of the notations we're going to focus on is called interval notation. And an interval is just a non-empty set of real numbers. So an open interval will always use parentheses. An open interval means that you're not including the A value and you're not including the B value. It's all the numbers between A and B. So you're probably familiar with writing those intervals in terms of set builder notation. So to the right, I have how you would write the interval in set builder notation, which is A less than X, which is less than B. For closed intervals, you're going to use brackets. And closed intervals actually include the A and the B. So closed intervals would use less than or equal to or greater than or equal to. And then half intervals use a combination of an open and a closed. One of the intervals I want to point out to you, though, is this one here, negative infinity to positive infinity. And that signifies all real numbers. So that means every number on the number line. You will always use parentheses around or next to infinities. So you're always going to use parentheses for positive infinity and negative infinity. Let's look at a couple examples. So we have to write each inequality using interval notation. So what I notice in A, it says that X has to be between 1 and 3 inclusive. This is your less than or equal to. So here we have less than or equal to, so I'm going to use a bracket, and I'm going to have a 1 there. And then I have a less than or equal to next to the 3, which is another bracket, and then 3. So that means all the numbers from 1 to 3 inclusive on the number line. So if we were to look at a picture of that, here's 1 on the number line, here's 2, here's 3. From 1 to 3 means I'm including all the numbers from 1 to 3 and every real number in between. In letter B, it says X is greater than 5. So greater than, I'm going to use parentheses. So that means it's going to be bigger than 5, but not including 5. So that's what the parentheses signify. Bigger than 5 means any number bigger than 5. So that would be from 5 to infinity. And we always put parentheses around infinity because it's a concept. It means basically that it goes on forever. In letter C, we have the notation written backwards. So you want to put the variable first. So here I would rewrite this and say X is, and you notice how the arrow is pointing to the X. I'm going to have to switch it around if I put the X on the left side, -2. So here this is saying X is less than -2. So this just means if I think of a number line, here's -2. If I go less than that, that would go this way to the left. So that's from negative infinity to -2. So you always put parentheses around negative infinity, and then 2 has parentheses because it's less than -2. Now let's try writing each interval as an inequality involving X, and then we're also going to draw a picture. So here I have one of these half intervals where it uses a combination of a bracket and a parenthesis. So if I was to visualize this, I have a bracket around 1 and then a parenthesis around 4. So remember, brackets signify closed circles and parentheses signify open. And then it's all the numbers in between. So if I was to write this as an inequality, I would write it using set builder notation. So I would put these braces and I would put x with the vertical bar. And that just means x such that here we know that x has to be less than 4, but it's greater than or equal to 1. And the reason I know it's greater than or equal to is because it is using a bracket and it's bigger than 1. But it's less than 4 because I'm using parentheses around the 4. If I take a look at letter B, this is the interval from 2 to infinity, and it's an open interval because I'm using parentheses on both ends. So this is just saying from 2 all the way to positive infinity. So if I was to write that using set builder notation, I would put x such that x is greater than 2. There's some properties of inequalities that are important to take a look at because they are going to be used when we're solving here shortly. So a couple things I'll point out to you, that this first non-negative property, it's saying that a squared is greater than or equal to 0. Basically, that's saying if you take any number and you square it, you're always going to get a positive number. That's all that means. If you have a number greater than or equal to 0, it's positive. So in plain English, this is just saying if you square any real number, the result is a positive answer. The addition and subtraction properties are just saying whatever you add or subtract from one side of the inequality, you'll do the same to the other. And the multiplication and division properties, I have stars next to 2 of the properties. If you'll notice, the signs switch around. So we start out with less than and it turns to greater. And then here we have greater, and then it turns to less than. So what this is saying is that if you divide or multiply both sides of an inequality by any negative number, the symbol will flip around. So what I mean by that is, if you have a less than, it's going to turn into a greater than. And if you have a less than or equal to, it turns into a greater than or equal to, and so on. So let's see how we can apply the properties for solving inequalities. And there's actually more properties on page 123 that you should look at in your book. Okay. Pardon me. So let's look at inequalities in one variable. Okay, you want to recall that you have the less than symbol, and then right next to it is less than or equal to. And here we have greater than, and then to the right of it, greater than or equal to. So when we're solving inequalities, there's more than one answer, and our job is to find all the values or the solutions of the variable for which the statement is true. So in the following examples, we're going to solve the inequalities, and we're also going to graph the solution sets and write our answers in both interval and set builder notation, just to get some practice. So in this first one, we're going to isolate the x. So we want to subtract 3 from both sides. And I'm going to bring down negative 2x is less than 5 minus 3 is 2. And then I need to divide by negative 2. And I'm going to put a red flag here. Okay, for beware. You're dividing both sides by a negative number. So remember, you need to flip the symbol. So this less than is now going to turn into a greater than. And then I have x is greater than negative 1. So in set builder notation, it's real easy. You just throw the x such that, and then just rewrite x is greater than negative 1. If we were to write that in interval notation, since I'm using greater than, I'm going to have parentheses, negative 1. And then if x is greater than it, it would be any number from negative 1 to infinity. And infinities always have parentheses next to them. If we were to visualize what this would look like, here's your number line. Here's negative 2, here's negative 1, here's 0, and so on. So here I would have from negative 1 all the way to positive infinity, if you want to visualize that. With inequalities, there's more than one answer. So if you were to plug in any number in that shaded part, like the number 1 is there, if you were to plug that into the inequality, it should come out to be true, right? So if you were to check it, if I did 3 minus 2 times 1, since 1 is in the shaded part, it should come out to less than 5. And 2 times 1 is 2, and 3 minus 2 is 1, and 1 is less than 5. That's true. If you pick a number that's not in the shaded, for example, negative 2, or even negative 1, since it's an open interval, it means I would not include negative 1. If you were to plug that in, you would get a false solution. Okay, in letter B, I need to solve for x again, so I'm going to move x to one side, so I'm going to subtract 2x, and I'm going to bring down the 7 is greater than or equal to negative 3, and then I'm going to subtract 7 from both sides, so I get 2x is greater than or equal to negative 10, and now I'm dividing both sides by 2, so negative 10 divided by 2 is negative 5. So here, this is saying all x needs to be greater than or equal to negative 5. So in set builder notation, I'm going to put x such that x is greater than or equal to negative 5. And if I was to write that in interval notation, I'm going to have a bracket, since it's greater than or equal to negative 5, and then infinity with parentheses. Remember, infinities always get parentheses. If you were to visualize this, again, here's your number line. There's negative 5, there's 0. And if you picture it, it's all the numbers from negative 5 to positive infinity would be a solution. Okay, in letter C, I have here what's called a compound inequality. Because it's two inequalities in one. So think of it like this. You've got negative 5 is less than 3x minus 2. And then your other one would be 3x minus 2 is less than 1. So you're splitting up the two inequalities. You don't need to solve them separately, though. So what you could do is just isolate the x. So I'm going to add 2 to both sides of the inequality. So I would get negative 5 plus 2, which is negative 3, is less than 3x, which is less than 1 plus 2, which is 3. And then just divide both sides by 3. So negative 3 divided by 3 is negative 1. And you get x has to be between negative 1 and 1. If I was to write that in set builder notation, I would have x such that negative 1 is less than x, which is less than 1. And in interval notation, I'm going to have 2 parentheses because it's an open interval. So if you think of it, your number line, here's -1, here's +1, and this is just saying all your solutions have to be between -1 and 1, not including them. The last inequality I'm going to solve for this section, you have this interesting notation with the -1. So if you'll recall from algebra, anytime you have an exponent as a negative, in order to make it positive, you would write the reciprocal. So you're just going to take the 4x minus 1, and if you place it on the bottom, now that's saying the same thing that you have written originally. So on page 123, if you refer to that in your textbook, there's a property called the reciprocal property that says, so on page 123, it says if A is greater than 0, then 1 over A is greater than 0. So here, think of this as A, and if that's greater than 0, then 1 over A is greater than 0. So I'm just going to take 4x minus 1 and place that next to the greater than 0 using that property. And I'm going to solve it. So I'm going to add 1 to both sides and then divide by 4. And I get x is greater than 1/4. So again, if you were to write that in interval notation, it would look like this. And if I was to, set builder notation, it looks like that. Interval notation, I'm going to have 1/4, comma, infinity.